I was really determined to find a way that I can make this startup, make the bridge between the science and the business become a reality. This is a polymer or a plastic that you can program to move in different ways. Our vision is to allow our devices to communicate with us via touch. And that's very important for people who cannot see so well. We have a vision that goes beyond that. We're very excited to see what happens.
Welcome back to another episode of the Startup Passport by Econsulate. Today we're joined by Mert Orhan A. You are the CEO and co-founder of HaptonTech. Thank you very much for joining today.
Well, it's my pleasure. Thank you for having me.
You went to a British school in the Netherlands, then went to the UK to study, and then you came back to the Netherlands to do your PhD there, and now you are also a co-founder. How did all of that appear?
Yes, I'll give you the full story. It's quite a journey. So even in my very early years, I was never sitting still because my parents' job took them around the world. I was born in Istanbul, in Turkey, but then when I was 4 years old, we moved to Romania, then to the Netherlands, then to the UK, then back to the Netherlands, and then I went to the UK to do my undergraduate and master's. Then I came back to the Netherlands to do my PhD, and here I am now. And that experience as a whole was really what defined me a little bit, because when you are in an international environment, you mentioned I went to the British School of the Netherlands in the Netherlands, you have a very different view of the world. You meet with many people from across the world, and my parents kept me at that school for quite a long time because they weren't sure if they were going to leave the country or not. So that's why I was in international schools for a long time, and it gave me this perspective of the world is your oyster. I was comfortable to go everywhere across the world. And I went to Imperial in London, and I was always interested in how technology impacts our life. So I was doing a material science course there. And during my time there, I saw a lot of technologies that I felt would be very interesting and impact many people in a good way, in a positive way. But I saw that there was a bit of a disconnect between how these technologies were developed and how the businesses were developed and how the business school ran. So I was always feeling like I could be the one to bridge that gap. So I also chose specifically during that time not to just do material science and engineering, but material science and engineering with management. Mm-hmm. So I tried to get into that world a little bit there. And when I finished my master's, I can make this startup, make the bridge between the science and the business become a reality. So I looked across the world, and funny enough, what I was looking for was very close to home. I found it in Eindhoven, at the University of Eindhoven, and there was this very interesting technology there that was soft robotics based on liquid crystal polymers. So to put it bluntly, this is a polymer or a plastic that you can program to move in different ways. The way I like to think of it is that it's one machine material. One material has all the machine inside of it. You can program it to move in different ways. You can get it to actuate or move between the two positions with light, heat, or electricity, and there's a lot you can do with that. So I thought to myself, this is where I need to be. I contacted the supervisor and I made clear my interest. And during the entire vetting application phase for that PhD that I wanted to do there, during the interview, I made it very clear to my supervisor already. I want to make a startup from your material, from the ideas that we can generate from your material. So then what happened was I finished my PhD at the beginning of this year, and here I am, wanting to make the startup a success.
And now your startup is specializing in smart haptics and optics. Can you give us an example of a real life use case where your startup could help people?
Definitely. So there are many ways that we can really apply our material, but what we really want to begin with is haptics, or the sense of touch, for people who really need it the most. So in general, our material, what we want to use it for, our vision, is to allow our devices to communicate with us via touch. But who is it most important for? Well, say your sense of sight and hearing is not as good. Then you rely on your sense of touch much more to interpret the world, interpret your environments, and also, if you want to use devices, connected devices. So that's why we're focusing on people who cannot see or hear so well, or deafblind, with refreshable Braille screens. So this is a device that people who cannot see or hear so well use to digitally read articles electronically by basically running their fingers across a row of pins, which can change configuration to make different Braille letters. And when they're at the end of the sentence, they can come back and it has refreshed, so they can read another sentence again.
So, and you mentioned Braille letters. These are the letters that people that have, let's say, hearing impairments or reading impairments. Exactly,
Yeah.
that makes more sense. They can feel the letters. So
Yeah.
this is a way of reading.
That's right.
Yeah.
It's a way of reading, and that's very important for people who cannot see so well. And that's how they really can read all the. You can't imagine how dependent we are actually on reading and being able to read. So this is really crucial for them. And because it's hard to digitize, it's really a barrier for them for the wider world that we know, with devices and all the online articles, everything. And with these devices, allow them to enter that world. But the problem right now is that these devices are very expensive. So if I told you, could you guess how much one of the cheapest of these devices costs? What would you say?
For someone to for like an individual person to buy?
Yeah.
I guess we're going into like the tens of thousands.
You would not be wrong. So the cheapest of these devices are 3,000 euros, while the most top of the range one is 25,000 euros.
Go up to, yeah.
And this is really not affordable for many people who cannot see or hear. And even people who don't specifically, per se, need it, just have low sight and low vision, they could also make use of it, but it's not accessible for this group of people because it's just so expensive. And the most expensive part of it are the motors they use to make the pins go up and down. And that's around 25 euros per motor. Say you need to make a sentence with 50 in a row, the costs start to add up. And the most sophisticated of them can use up to 300 or more. And what we can do with our technology is replace these motors just with our film of plastic, can do the same effects, bring that cost down from 25 euros per motor to 50 cents. So we can make a very big difference in the cost of these devices and make it much more accessible for everyone across the world. So that is what we want to do at the beginning with our device. We want to make some very clear social impact. But we have a vision that goes beyond that. So it's not such a big jump to go from refreshable Braille screens to haptic coatings that we can put on displays that are also transparent. So I have a version here actually that is on the more transparent side that we're working towards, so that you can't just see images, you can also feel them. So say you want...
That's an interesting point. How can you feel images?
Yeah. So say the Remarkable, for example.
Yeah.
That has a textured screen, and it makes you feel like you're writing more on paper. Say you can have the same thing, but now you can switch how the texture feels to different materials. So you can choose what you're drawing on the tablet. Or say you want to go online shopping. You want to feel your fabric, right? That's why we still go to the shop to buy our clothes. But what if you could do that on your tablet? You feel the image, and the texture of that part of the screen can be the same as the texture of that material.
And essentially, do you need to change something about the tablet then? Or do you have an additional device that goes onto the tablet, let's say, and then you can use that?
Yeah, so that's the thing. This is why we see this as a future vision. There's a lot that needs to be done here, not only in terms of integrating haptic coating onto a device, but also programming of it. Now you're not just programming pixels, you're also programming haptic pixels. So there is a long ways until we might get there, but we envision going there. That is our mission. That's our vision.
And right now, also to wrap it up, what is it you're looking for right now? Because you just mentioned it's probably far ahead in the future that all of this can be worked out, but you are already working on it now, and you're very, very passionate about it. And
That's right.
seemingly there's a market for it, and people that will very much benefit from it. So how are you trying to move forward with it, knowing that it might not be for the next years?
So we want to begin with the people that need it more urgently and who can make use of it right now. So the Braille refreshable screen that I was talking about in the beginning, we're closer to building that. And for that, we see a runway of maybe 1 to 2 years until we get there. And we want to, at this moment, grow the team to be able to do that device integration process. Because at the moment, the team consists of mostly the material experts. We're actually quite new on the scene. And that's what we're looking for right now. So we're looking for an investment of up to €1 million to be able to build that team and build that first proof of concept, which will not only help us build that first device with a refreshable Braille screen, but we're actually being contacted by some larger companies asking how we can do that haptic display. It will also go towards that. So even though there are multiple steps to get there, we feel like we can ride the applications to that final vision of getting it onto a display. So we're very excited to see what happens.
Yeah, and that will be very interesting to follow in the future. Thank you very much for all of these insights, and good luck with everything coming up with HaptonTech.
Thank you very much. It's a pleasure.